Have you ever wondered how your phone recognizes faces in photos, or how Google Lens knows what's in an image? Today in Project 6, we're going to build our very own image recognition program in Python. In just a few lines of code. By the end of this video, you'll understand how computers can tell the difference between a cat and a dog using the power of simple image comparison. Alright, before we jump into code, let's understand how machines see an image. To a computer, an image isn't a photo, it's just a big grid of numbers. Each pixel is represented by 3 values: red, green, and blue RGB, each ranging from 0 to 255. So, for a grayscale image, each pixel has one number, from black 0 to white 255. When we compare two images, we're actually comparing thousands of these pixel numbers to see how similar they are. If the pixel patterns are almost the same, we can say the images represent the same object. Now let's install the tools we'll need. We'll use 2 Python libraries: OpenCV for image processing, NumPy for fast math operations. Open your terminal or command prompt and type these 2 commands. That's it. You're now ready to code your own image recognizer. Alright, now that our code is ready, let's set up the project folder. First, in the same directory where you saved your Python file, create a new folder and name it Templates, all lowercase. Inside that folder, add the images you want your program to recognize. For example, you can add files like cat.jpg, dog.jpg, and car.jpg. Then, in the main folder, keep one image named test.jpg. That's the image our program will analyze and compare against all the templates. Create a new Python file and name it project6_image_recognition.py. So your folder structure should look like this. We import CV2 for OpenCV, NumPy for number operations, and OS to handle files. Here we're loading all the images from a folder named Templates. We read each image in grayscale and resize it to a standard size, 100 by 100 pixels, so all images are easy to compare. This is the brain of our project. We load the input image, resize it, and compare it pixel by pixel with every template image. CV2.appstiff gives the difference between 2 images. The smaller the sum of differences, the more similar they are. Finally, we load our templates, test an image, and print the best match. Now run your program. If your test image looks like a cat, you'll see something like. What we just did is called template-based image recognition. It compares pixel brightness patterns to see which image looks most similar. This is the basic idea behind more advanced recognition systems that use neural networks. They just analyze millions of pixel patterns automatically. And that's it. You've just created your own image recognition program. Try adding more categories like cars, birds, and faces. Or upgrade it by using OpenCV's CV2.match template, or even a pre-trained deep learning model. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon.